exponents as repeated multiplication. So let's take a look at this exercise. And it says we've used exponents a little so far, but they will become much more important to us as our studies in algebra progress. So the key here, and they've already made it bold for us, is that it helps us. Maybe if I could use my highlighter here. Let's see if it'll work. There it goes. Kind of repeated multiplication by the same number. So it says, by definition, if n is a positive integer, okay, meaning 1, 2, 3, and so on, then x to the n would be x times itself n number of times. Okay. So it says, write out what each of the following exponents means as an extended product and then find its value. So that first one is 2 to the 4th, so we know that that means 2 times itself 4 times. And I'm trying to get that in there. There we go. And doing that multiplication, we end up with that equals 16. 3 squared, 3 times itself, twice. 5 to the third. 5 times 5 is 25, times another 5 is 125. Okay. So now let's turn this a little bit more into algebra, and let's throw in some variables into that mix. It says write out what each of the following terms involving exponents mean as an extended product. Carefully consider your order of operations. So what does x to the third mean? It means x times itself 3 times. Letter B means x times itself twice, and then y times itself 4 times. Okay, they're your extended products. Then part C, 2x all raised to the second, so that 2x in parentheses means we have 2x times itself 2 times. Then next row, we have 4x times itself 4 times, y times itself 3 times. Letter E, 9x squared to the third power. So that means 9x squared times 9x squared times 9x squared. But we could also extend out those x squareds. So 9x times x times another 9x times x times a third 9x times x. I don't know why that's shifting around. Hopefully it'll stop. And, oh, I don't know what it just did, but it seemed to move. Let's see. Technical difficulties here, folks. Gracious. Let's see if I can move this around. All right. Just one more time, shove that over so we can take a look at letter F. Negative 4x to the third power, and that's raised all to the second power. So let's see what we can do with that one. So negative 4x to the third times negative 4x to the third 2 times. So let's expand out that x to the third, negative 4x times x times x. I'm going to even put that negative in parentheses, that negative 4. And then I have negative 4, again, x times x times x. Sorry, I had to squeeze that in there a little bit. Okay. So, looking at this next exercise, let's see if I can move my screen. There we go. So it says one of the nice aspects of exponents is that they follow very predictable patterns, often known as exponents rules. And the author of this sort of textbook that we use does have a sense of humor. He says, and they do rule. Let's figure out the simplest one in the next exercise. So write out each of the following products and then express them in the form of x to the n. So x squared, x to the third means x squared, so x times itself twice, and then that x to the third. So really, what does that mean? It's just another way of saying x to the fifth. So you guys, I'm sure, will pick up on the pattern quickly. It's happening here. So x to the fifth times x squared. And what do we end up with there? We end up with x to the seventh. See what's happening with those exponents? Make the prediction on this last one. If I wrote out x to the fourth, so x times itself 4 times x times itself 4 times again, you should end up with x to the eighth. So what's the prediction? What do we do with exponents when we have like bases? There it is. So what's the pattern? So our generic rule, if it has the same base, that's the key. So x to the a times x to the b, they both have a base of x. So x to the a plus b. Like bases, add the exponents. So this next paragraph talks about internalizing the rule. So meaning, say it so much to yourself that it becomes automatic. Like bases, add exponents when you're multiplying. So exercise 5, quickly write out the following products raised to a single power. So that would be x to the 13th, x to the 9th, y to the 8th. Like bases, add those exponents right up to simplify. All right, so it says, so we're going to list out the steps in simplifying this product. 5x cubed times 2x to the 7th to simplest terms are shown right in what justifies each step. So here's the initial problem. Okay, never seem to underline things. There we go. And what did we do from the left side of the equal sign over here to the right side? Well, we just shifted that 5 and that 2 around. So we changed the order. So that's the commutative property. I'm going to abbreviate. Commutative property of multiplication. Okay, because we can have the commutative property of addition, because we can change the order of addition, but we can also do it with multiplication. So I'm going to be real specific here. Commutative property of multiplication. Step 2, what happened here? So now we shifted some groups around, or we made some groups. So that's the associative property of multiplication. We use ditto marks. You guys know what those mean? So if you have something above that's the same, you can use those two little marks. Those are ditto marks instead of rewriting exactly the same thing. And then the last step, what happened? We went from 5 times 2 to 10 on the left-hand side there. And then what did we do with that? That x cubed times x to the 7th, we got x to the 10th. That's our exponent rule. So instead of write down exponent rule, because we're going to learn a couple more, we could say something like, if you're multiplying like bases, we add exponents. Okay? Again, put that in your brain. You want that to be accessible very quickly, that property. All right? So now this last one says, rewrite each of the following as equivalent expressions in simplest exponential form. So we've got our coefficients here to these terms. 2x to the 7th times 8x to the 5th. So we're going to multiply 2 times 8, so 16. The like bases are the x's to the 12th. Letter B, negative 4 times 2 is going to be negative 8. And then x to the 3rd, x squared. Again, like bases of x, so add those exponents. And this last one, I'm going to write it out twice. And then I'm going to use my new rule. Holy cow. Today is not my day with this stylus. So, negative 6 times negative 6, 36. X, like base is x to the 3rd times x to the 3rd gives you x to the 6th. And we're done. 11 minutes flat.